Okay, hello everyone. Good morning, good afternoon, good evening, wherever you are in the world. Thank you for joining us. We're here, we have two amazing speakers. We're here to talk about how to auto-generate mocks with MockLab and UP9. And we have two speakers here with us today. We have Tom Akehurst, who is the founder of MockLab. When I asked Tom to describe himself, he said he was a software developer with the habit of finding interesting ways to break things, which I think is a really good way to describe any developer. So he created WireMock and MockLab to help teams keep shipping when APIs are everywhere. He founded MockLab 5 years ago, and you'll soon see how great it is in the upcoming hour. And we also have our own Rafael Botbol-Weiss, who is the VP of Customer Experience and co-founder of UP9. Previously, he was Director of Professional Services at BlazeMeter. He also founded BlazeMeter Labs. BlazeMeter was acquired by CA Technologies and then acquired by Broadcom, where he was the head of customer experience. Like I said, you're in for a treat this evening, and let's get started. So what is our agenda? We'll start with some housekeeping, and then we'll talk about Monolith microservices and why. We'll talk about the challenges of microservices, how Mocks ease the pain of those challenges. We'll see a demo, we'll have a short summary, and then we'll have time for Q&A in the end. So in terms of housekeeping, you'll get the recording after the webinar. We have a Q&A session in the end, but you can just ask at any time you want. There's a QA button at the bottom of the panel. You can just click on it and ask your questions. And at the end, we'll be sending out a survey. We'd really appreciate your participation. It helps us create better and more fitting content for you and according to what you're interested in, so we can create more good webinars for you. Speaking of which, we have a monthly webinar, which you can find on our LinkedIn or on our website. So I encourage you to go in and find what we're talking about each month. And with that, I'm going to pass it over to Rafael. Rafael.
We discovered that we can quickly get what we need through the computer. And then, oh my God, mobile came, Web 2.0. We can now have the power of the 60s computers that goes to the space in our pocket, probably better than that. All the evolution of 3G, 4G, and then we get to 2010, where Netflix, Slack, Uber, everybody kind of transitioned to the ability to deliver fast, agile transition. I can ship my code anytime I want. And now, in the cloud native environment, it's not just that we have a couple of APIs, we have hundreds, thousands of APIs running in Dockers, running in a serverless somewhere. Basically, it's someone else's computer. And we need to deal with the amount of APIs and code that is being generated. So why do we do that, right? When we moved from the Monolith and microservices, first, it allows us to take a big problem we called software and break it into an easier, smaller problem. The second thing is we can now react faster to changes in the market. So with Waterfall, we were developing like for 6 months, then releasing, and then another 6 months and releasing. And just think of, you know, the customer experience. If you had a bug, if it wasn't critical, sometimes even if it was critical, you need to wait 6 months to even get that bug fixed. Today, that's unacceptable, right? You have a bug, you get it tomorrow probably. Another thing is that we started to have more and more developers. So just think of like how many developers we had like 20 years ago and how much we have right now. It's amazing. And we need to manage those teams. And those teams want also ownership and the ability to kind of, in the DevOps culture, to kind of be able to own it. I craft my software, I want to ship it. I want to create functionality and services reuse. So, hey, I developed a catalog, someone else can use it. They don't need to develop their own catalog. And we want to also be able to decouple the technology choices that we do from the functionality of our software. So I want to go to event streaming. I can use maybe Kafka, maybe I can do RabbitMQ. I don't know. I want to look at container technologies. I want to switch from ECS to Kubernetes, vice versa. All the technology choices comes with a lot of effort, and you need to test that, but it doesn't really have to do with the application that is a website, right? So how we decouple that? How can I do those experimentations? Basically, I take a monolith, I can now move it to microservices. And in the monolith, we had A call B with a function code. All the variables were in the same namespace, probably, maybe a little bit global, maybe somewhere private. But all of a sudden, those microservices that represent exactly the same application usage are now decoupled. All those functions are now remote procedure call, maybe APIs, right? Or WebSocket. And also, remember, we had that huge database. Now every service has its own database, and maybe they're all communicating through a queue. Or you have a backend of APIs here that serves all the others, which is great because now they're all decoupled. And that's great because now if B has a lot of performance or a lot of users that come with some performance degradation, I can just spin up more Bs and save costs. And I don't need to care about A, C, and D. In the monolith, I had to just take the whole bunch of the front end and just couple it and duplicate it, even though only B had the spike in the requests. So this is great. This is a very high level, but as we say, the devil is in the detail because this transition brings some new challenges that we have. And Tom and I kind of discussed on that, and we took like Tom is the developer between us, and I'll take the more of the tester role. So Tom, you've been here quite a while. For developers, what are the challenges that they need to deal with?
Sure, yeah. So there's a whole host of new challenges that you don't have to contend with, particularly when you're working in a sort of monolithic environment. One obvious one is that your sort of personal development environment, the one running on your workstation or laptop, can be a lot of effort to set up, and it becomes harder and harder to set up the more services you add to your application. So I've seen this more than a few times where a company will start out with a handful of microservices, and you can run them all on the same laptop, and it's all nice and easy. But then they quickly scale out and they end up with 50 or 100 or more. And suddenly that becomes a sort of unmanageable amount. You can't run them all, and you spend all this time sort of setting them up and configuring them and all that kind of thing. So that becomes very difficult. Secondly, and kind of related to that, is the sort of inherent instability of the services that you're working with as dependencies. So the great thing about microservices is that everybody else can change things and deploy new versions whenever they feel like it. The downside for you is that everything around you is changing all the time, and the environment you've spent all this time setting up, maybe someone ships a new version of a service and now the data you have is invalid, or there's more work you have to do to get it into a state where you can start testing again. And so you're in this state of kind of constantly shifting sands where you can end up sort of spinning your wheels a lot, spending a lot of time just getting things to a state where you can test against it. Another issue that really commonly crops up is what happens when you're developing a new feature, but you need a new API feature from somebody else. The sort of one way of dealing with that that commonly occurs is that you sit and wait. So you kind of agree what this API feature is, and then maybe you wait for the API team to work for a sprint or two, and then they ship that feature. And then after that, you can start working and you can start building your new feature against that. But there's a couple of issues with that. Obviously, one being that it's not very productive for you if you're sitting on your hands waiting for a new API to be shipped. And the other issue is the kind of building the bridge from both sides, and the two sides not quite meeting in the middle. So you possibly both go away with a rough idea in your mind about what this new API feature should look like, but actually when it comes to bringing them together again, you realize that your assumptions were slightly different, or you had sort of slightly different designs in mind. And if you've gone down the route of waiting for the API team to ship this new feature, then that feedback happens very late in the process, and it means that it's more costly to correct, and you've waited longer before you've realized the error. So that can be kind of a difficulty. End-to-end tests, if you rely on these, they tend to be sort of slow and flaky. Again, you have this similar issue to the first one I described, where the more services you add, sort of the worse this problem becomes. The harder it is to get kind of a reliable test run it's sort of first time after you change some code or something like that. And I suppose the final thing, again, in this given this situation where maybe you've started with only a handful of microservices and you're running them all on your laptop, and maybe you're running end-to-end tests against all of them, is in that scenario you run the risk of unintended coupling. So if you're always running tests against all these services, then you can find yourself in the situation where you've built the dreaded sort of distributed monolith. You end up having to ship all of these services simultaneously rather than getting the kind of independently releasable quality, which is one of the big upsides of microservices. So then you have the worst of all worlds. You've still got these all these distributed components to manage, but you still have to do these big coordinated high-risk releases that end up not happening very frequently because they're so difficult and they're so risky. So clearly that's something we want to avoid as well.
Yeah, that's the developer side of things, but we, the testers, also have problems, because now everybody can ship their code anytime they want, and there are so many services, so many endpoints. Every change, the whole agile transformation is kind of adjusted to make developers as efficient as they can, throughput, get your code there, and the testers now need to kind of chase the tail and how we co-op with that. Every integration environment and every integration build can have multiple code changes, and if you find a bug, it's really hard to trace it, because in the end-to-end days, you just test it from the front end and maybe some of the APIs, but it's already too late. The second thing is we need isolated environments. Like if I want to do performance tests, if I want to check some kind of an edge case, I need to have all the databases, all the application in a certain specific state in order to test that. And I need to ask my DevOps to maybe spin another namespace for me, my Kubernetes. I can definitely not do that on my local environment because there are too many services that I need to just spin on my Docker machine, or sorry, on my laptop. And I just basically now put more burden on my DevOps to create those isolated environments for me. So I become kind of a test ops, and I just learn Kubernetes in order to just get the job done. And then we talk about the complexity of the test. So for example, I got my certification, I can do that. Now I need to kind of figure out how I bring all those services into exactly the same state, but maybe I can do that, but now I need to also do all the queues in exactly the same state. So if service A communicated with service B through a queue, I need to have that queue in that state as well. And this is a little bit more trickier, and you end up doing a lot of work to just check a couple of APIs. So what we basically do, unfortunately, we fall back to our end-to-end tests, and we start testing the whole application. But the problem with that is if Tom is working on a couple of endpoints in catalog service, or somewhere after, like, behind the backend, couple of services behind the gateway, they want to test only those 3 endpoints. Now I will tell Tom, hey, here is a Selenium test that goes through the front end, get to the back end, move to the back end for the front end, then it goes into some services, and then at the end it will test your endpoints. Good luck. It's going to test the whole application with actually, you don't need to do that. And the second thing is resource intensive. It's Selenium. I need to spin up the front end for that. I need to spin everything for that. And it's going to take a long time, and it's going to be slow at the end. Not to mention that if you found the bug, root cause analysis, now how would Tom create the test for it? As a developer, what? You will enhance the Selenium script? How can they create a very simple functional test to test that endpoint? That's tough. And it becomes, us versus them, versus both of us want to create equality, because I keep reporting bugs. It catches the developer way after they finish that task, and it's in a later stage. And now we start to fight if it's like, whose problem is it, and they can't reproduce it. We all know about the blame button of GitHub or the can't reproduce in Jira. So it's not productive. And it's we want to be able to kind of help developers to catch those bugs faster in the way that it's easy for them. So Tom, how Mocks goes into that whole story? Help us here.
Yeah, so mocking the APIs you depend on can yield a lot of benefits, but based on the challenges that we've just described. So to start off with, you can build much smaller, cheaper to run, more stable kind of isolated environments. Both on your laptop and in your cloud environment, in your Kubernetes cluster, wherever you're working. Mocks servers tend to be very, very small and light relative to kind of full-blown services. So as I say, they're kind of cheaper to run, and you can kind of create this sort of this outer shell which you've got full control over around the whatever it is that you're actually trying to interested in testing, rather than this sort of endlessly sprawling network of real services that all sort of in turn depend on each other. So you can do that first of all. Secondly, setting up and changing data is often a lot easier when you're using mock APIs than when you're trying to manipulate that data in real services. It varies a lot between services. I mean, if you're working with a microservice that's been delivered by the team sitting next to you, then maybe you've got some flexibility there, and it's quite easy to set test data up. But I'd invite you to think about the example of, say, a social network. So say if we're building something against the Twitter API, and for a test case, we want a user who has 1,000 followers that have specific qualities, and we want to kind of this specific kind of test data scenario that we want to work against. That would be pretty challenging to set up. It would take a lot of work and a lot of effort to sort of set this up in Twitter sufficiently for us to be able to run this one test case. Whereas conversely, if we mock the response of an API call from Twitter, then we can put whatever data we want in there. We can simply construct the response JSON to be to have exactly the data we want. So we make cases like that far easier and cheaper to work with. It's also easy. It makes it much easier to extend APIs. So as we discussed, as I mentioned previously, you have this issue of you have a new feature you're building, and it depends on a new API feature that is coming down the pipe at some point, but it's not there yet. And if you're mocking that API, provided you've kind of agreed with the team who are shipping it what this enhancement should look like, you can simply go and edit your mock response to make it look like the sort of target state of this change, and then you can start building. And this has the advantage that it gives you early visibility of that API design. It gives you a chance to figure out, does this really work for my use case, or is it actually the wrong API design? I can provide that design feedback to the team who are implementing that API early, so they can course correct and they can build a better version of that API sort of early on, rather than, as we mentioned before, that's finding out at the end of their sprint or their iteration or whatever they're working on. So that can be really valuable, and that sort of having that shared asset, that mock implementation of that API as a resource that both the producing and the consuming team have got access to, is valuable in sort of reducing those misunderstandings and ensuring that you're that you're collaborating well. Reduces the opportunity for that sort of missed two halves of bridge.
Yeah, it's actually a good point here. It's not just that we get the job done; it's that how we do it. And I don't know if you guys probably want to look at the contract testing as a methodology of development. But if we're working on a feature, and actually we'll show it in the demo, we can collaborate on how those features work. So if, for example, I own catalog and Tom needs to use that, and we need to do some kind of a discount JSON, right? Tom can literally create that extension, share it with me, and I can look at it and say, okay, he expects that here in this format, this JSON. I can already give him feedback about that. And it's kind of, we're two teams trying to achieve something, not, just who puts the code faster. So check it out, contract testing as a methodology to how microservices team can develop software.
Yeah, absolutely. So additionally, so I mentioned previously, a common problem is when you've got new versions of services popping up all the time, other teams shipping, shipping new implementations of things, that can contribute to a kind of unstable environment to work in. Sometimes maybe your esteemed colleagues don't always ship sort of perfectly robust versions of those services every time. So maybe your test environment is working 1 minute, but then a new service gets released and suddenly it's not working anymore. And if you have lots of services around you, then that can result in a frustrating loss of productivity. So you can sort of regain control of your environments and ensure that you're not being affected by by those kinds of problems so easily by substituting in mocks. There's a few other cases as well, like if you're using an external API from a vendor who charges you by the API call, then it might be that your testing becomes quite expensive. That every time you do a test run, you're charged however many dollars, and you'd rather not do that. So you can substitute expensive services. Likewise, when you're performance testing, you might find that your suppliers they provide rate limits, or they apply rate limits rather, and or they outright refuse to let you performance test against their sandboxes. So this is pretty common with a lot of APIs, where they just say, sorry, you can't do it. You can do functional testing only. So being able to substitute a mock which is appropriately scaled for performance testing means that you don't have this problem. You can do as much performance testing as you like, and you're not going to get any angry letters from your external suppliers. Another benefit is that you can run kind of negative test cases and sort of resiliency test cases that are quite difficult to implement otherwise. So if you want to know how does your app perform when the API you're calling is returning 503s, you can't always go to the supplier of the API and say, hey, can you just generate a fault on your API for a few minutes? I just want to see what the test outcome is going to be. You don't always have that option. Whereas again, if you're using a mock rather than the real thing, then substituting a response for a 503 is pretty straightforward, and you can do other things like adding delays, generating network errors, sending bad data. Any kind of nasty edge case you can think of, you can quite easily construct. And likewise, that works for both functional and performance testing. So if you want to say, I want 5% of my my responses to be errors while I'm running a performance test to make sure my app stays stable. I want to raise the the average latency of my payment gateway. I want to simulate a kind of Black Friday event where my payment gateway is under lots of pressure, and I want to make sure my app doesn't fall over when that latency goes up. So all those kind of things that are quite challenging to set up when you've got a fully integrated real system start to become quite straightforward to do when you're using mocks in lieu of these things. And the final point worth making is about the actual performance of the mocks versus real APIs. So it's not uncommon for a real API to say take 300 milliseconds to return from a call on average, whereas mocks are very simple. They're returning canned responses or only very trivial logic, and a mock API might return in 15 milliseconds. So if you have a non-trivial test suite that's exercising your application very heavily and generating lots of these calls, that can add up very quickly to much faster test runs. And I've certainly seen in the past sort of 5 to 10 times performance speed ups, but running your test suite. So you can go from things taking an hour down to taking a few minutes, and that has a huge upside in terms of team productivity. Your cadence for shipping things goes up enormously when you can run your test suite quickly. It means that developers can just run the test suite on their laptop before committing, rather than those tests kind of happening in a pipeline step somewhere down the line, by which time everyone's kind of forgotten what they were doing and moved on to something else. So it has an enormously positive benefit for your workflow and your the sort of your level of productivity as a development team.
Yep, it's what we're going to show you today, how we're going to do that. And we kind of put the barrier real high Hopefully the demo will show you how you can do that. And what we plan for this demo is we just installed a simple WebSock application. It's open source. Anybody can just go and download and do that themselves. So actually, you can do that the entire demo tomorrow if you want to do that by yourself. And I installed UP9 and viewed the traffic that was generated by me just going through the browser and running the tests that WebSock provided. And UP9 generated artifacts for me. It basically generated the Open API spec and the test and the mocks. We're going to create an isolated environment for our use case. And in this case, I asked Tom to develop a new feature and also fix a bug and kind of test something in our catalog and front-end flow. So he's going to also enhance it quite quickly. And also, we're going to show you how we debug that, and actually, you know, in a multi-team environment, how we actually experience against the mock, how another team can actually go and harness what Tom just did. So with that, let's jump right to the demo, and I will just go to UP9, and what you see here at the high level is the representation of the WebSock application. So the WebSock application is a website. Tom will show it during the demo how it looks like. But from the backend side, you can see all the services, and it's very easy to understand. Here, the users are coming to the front end called orders. Orders does something with Kafka and shipping, goes back. And in our case, we're going to kind of go and zoom in on this area, the front end and the catalog. Okay, so for me, for example, if I would like to know how to work against catalog, I can just go to my contract page, look for catalog here, and I can see the service. Again, I can see all the services here, but this is the implementation, the APIs that we see catalog is exposed. So we have a cool GET request here, and we can get the size of things. And I want to focus on the actual ID of a catalog. And I can see here, for example, I have the schema. I can actually go and see the full Open API schema and understand the arrays. Sometimes that's good, but you know, for example, the type is the price type is number. Is it an integer? Is it a float? I don't know. So sometimes traffic is better than schema. You can just go in here, look at the traffic that you had, look at the request that you generated, look at the response that you got, and kind of see, oh, I can see that the price is actually a float. This is an integer. Here is the array of tags. This is very easy for me. And I can even go here and just do quickly execute, do something like a try now against that, play with the system, learn more about that, all from here. Now, today, what I want to do is gonna take that and prepare it for Tom to just use it as mock. So what I will do, I will just do a short export. And what I'm going to do also is, where is it? And Finder here. UP9 just created a zip file for me with all the artifacts. So I can easily go and see, for example, the contracts. Everything is in JSON, Open API spec, tests. So the test, PyTest, JUnit, just whatever you want. And of course, the mocks. And I'm going to go to MockLab. And I'm going to say, hey, Tom, you asked for an environment. Either you can do it yourself, but you know, I just did it for you. Let's import. Just drag and drop the entire warmock folder here. And voila, now I have all these application services ready to be used as mocks. I didn't do anything. Like everything was machine generated. And from here, Tom, please show us how we can enhance those mocks and create features and develop bugs. Or actually, yeah, develop bugs.
Okay, then, great stuff. Okay, so I'm going to reprise my role now as front-end developer. If I hit refresh on here, I should see the stubs that have been imported by Raphael, so that's all good. So what I want to do, I'm running the WebSock application locally. So to give a little bit of detail, this is a sort of example microservice system that was developed by Weaveworks as a sort of archetypal kind of microservice e-commerce application. So it's written in a variety of languages. It runs in Docker Compose or Kubernetes, or I guess some of the other sort of container scheduler type products as well. And what I want to do as a hypothetical developer of this application is I want to work on a specific part, and I want to sort of gain some control over my environment by mocking parts of this application. So let's say I go into a product detail page. So pretty typical product detail page with a description, with a price, title, pictures, that sort of thing. And at the moment, this is all the kind of real implementations of the services running. But what I want to do is that I want to substitute the catalog API, the one that is feeding most of the data in this page, for a mock, so that I can start playing around with it and doing some testing. So I'm going to open up a console window, and I'm quickly going to go in and edit this endpoints file, and this controls where the front-end application, what the sort of base URLs are for all of the different services that it uses. So I'm going to uncomment this one, which is this webinar.mocklab.io, which is the base URL for our mock API that we're using. Excuse me. I'm going to comment out the one that it's currently using, and I'm going to do a quick restart of this container so it picks the change up. And now I'm going to refresh this page, and all being well, we should see something different. Okay, so it's the same product page, but we're getting some different data. And the reason we're getting some different data is we're now getting the data from the stub that was captured by UP9 and imported into MockLab. So if I hop back over to MockLab now, I go into the request log, you can see there are these two requests here. So this is the front end application now calling MockLab instead of calling its own service. If we drill into here, so this catalog /UUID call, this is getting the product details. So we can see in the JSON here that there's a load of essentially the data that we saw presented on that web page. And MockLab gives us a link. So if a request comes in and it matches it to a stub, then MockLab gives us a link back to the stub that served the data. So if we click on that, then here we are. We are looking at the configuration for that stub. So I'll quickly run through the sort of the relevant bits of the anatomy of this. So there's the request method. It's a get, fairly straightforward. There's the URL path. Now you'll notice it's got this kind of regular expression part here, and that essentially means it's a wildcard. So this stub will match any request for a catalog item, and it's basically saying I don't care what the ID is. If a request comes in for a catalog /any ID, then we'll always get this response back. So if we scroll down here, then this is the response part. So we're getting a content type of application JSON. And then we're getting this JSON body, and I'll hit indent here just to so you can read it a little bit better. So yeah, this looks more or less the same as the response that Raphael showed you in the test request that he made in UP9. So now we've got this, we can start having some fun with it and changing things. So say we wanted to test, what happens if there's a really large price on the page. I don't know why we do this with socks, but if you'll bear with me, we might want to generate a random price and make it a very large number just to make sure that the layout of the page still looks okay. So I'm going to use this templating helper in MockLab called random value, which lets us generate random values, quite obviously. I'm going to say the type is numeric. And we'll say the length is 12, so that's going to be a pretty large number. And if I save this, and then I go back to this page, and all being well, when I hit refresh, there we go. We get this slightly bonkers price for a pair of socks. And if I refresh again, then we get a different bonkers price for a pair of socks. So that's a fairly trivial example. But as you can see, what this allows me to do is very quickly work with different test data. I could put a load of, say, exotic, sort of non-Latin script into the description if I wanted, or I could try an enormously long description that might ruin the page layout or something like that. as I mentioned before, I can also kind of do things with delays and faults. So for instance, I could say, what happens if the API takes 5 seconds to respond? Is that going to cause a problem? You know, because normally we'd expect it to respond much more quickly than that. So let's go back in here and hit refresh again. And okay, so we've kind of got this blank page. It sort of looks all right, but there's some boilerplate, and there we go. It appears after a few seconds. So maybe we're not so bad there. If I want to start getting really nasty though, I can inject some network faults. So I'm going to make a clone of this, and let's just call it catalogizing with a fault. And so one thing we can do here is if we want to, we can create stubs that are more or less specific. So rather than doing this kind of regex wildcard like we did last time, in this instance, I'm going to say we want to only match this one particular piece of data. And this is a really useful tactic to use. So you kind of say, if I hit this piece of data, I get this fault. If I hit this piece of data, I get this fault. Otherwise, I fall through to the sort of generic wildcard and I get something that's kind of on the happy path. So that can, you can have sort of examples of different products in your catalog, for instance, that all trigger different errors. So let's do that in this instance. So let's take this delay off first of all. And then we'll switch to a fault, and we're going to say we want to do a peer connection reset. So this is the server will send a reset packet to the client sort of before it's even sent a response. So bad network error, but it's the sort that can happen when web servers are under pressure. It's a sort of realistic fault that can happen with APIs when they're under load. So we might want to know what happens here. So let's go back into here. Let's open our console as well, just so we can see a bit more clearly what's going on. So now if I hit refresh again, oh dear, again we're in this situation where we've got this kind of boilerplate page, we've got the wrong description, no image, no explanation to the customer as to what's happened, and that's not so nice. And if we look down here, we can see in our console that the back end for this app returned a 500 error, and it's got this econ reset in there, which quite clearly indicates what's happened on the back end and why it didn't work. So again, we can, if we want to start thinking about, we might want to put a retry mechanism in there. You know, that's quite a common way of dealing with these kinds of problems. If you've got sort of intermittent network faults, if you have a retry mechanism in there, then as far as the customer is concerned, everything was fine, and you eventually render the page. And this makes it easy to test those kinds of sort of countermeasures against faults. And at the very least, you can prove that you're showing your customer something nice rather than a horrible error message or a blank page or whatever. And the final thing I wanted to talk about, so we've mentioned already the notion of being able to kind of extend our mock API sort of beyond what's actually been implemented for the in the real thing. So if there's a new feature or a new element or something like that we're planning on building a feature, a feature of our application against, then we can add it to our stubs. So I'm going to go and find our default catalog item again, and let's get rid of the delay on that. First of all, so I'll use this example of say we wanted it to add a sort of a discount, discount label onto here somewhere, and we wanted the actual amount of the discount to be driven by some data in the API. So rather than waiting for them to sort of implement that, to add that data into the real implementation, I can just say, well, we've agreed with the catalog API team, they're going to add a discount field on here. So I'm just going to add an example of it and save it, and then off I go. And the advantage of this is that I can write some code to make use of this. And I might look at this and think, actually, maybe a string isn't a good idea here. Maybe I need to do some calculation based on this. So a string with 10% in it is an inconvenient representation to use to do that calculation. So maybe I'll change my mind and say, actually, do you know what? Should we have it as a decimal instead? And then my logic is much easier. And as we mentioned before, we can use this to kind of stimulate some early discussion with the team doing the implementing the code. We can say, do you know what? I know when we agreed it originally, we said it'd be a string, but actually, can we change it to a decimal because I've realized I need to do this? And that conversation can happen very early in the delivery life cycle rather than only happening at the very last minute. So now that I've saved that, obviously I'm not going to go and hack a change into the front end that makes use of it, but hopefully you get the idea. But what we will do, I think, to sort of close the circuit, so I can now pass back over to Raphael, and he can now retest this and pull it back into UP9. So if I share my screen, can I do that, or can you take the screen sharing? Of
yeah.
There we go.
Sure. You see my screen?
Yep.
So, for example, Tom just told me, "Hey, Raphael, I implemented the discount in the mock. You're the catalog provider. Can you quickly give me some feedback about it?" So I go to the MockLab to MockLab and just take the webinar from here, the actual string. And now I go to UP9. All I need to do is just change it to the mock, right, and execute. And what will happen now? Sometimes those kinds
so that's the fault response that I implemented there because you used the same ID. So
let's just check another ID. No problem. Here is another ID. I can just try now. That's the beauty of it. I can just have all those data waiting for me. Technically, even in the data of the test, I can see that here. So quickly just do execute. And now I see I got 200 OK. And I can look at the response and I can see we have the discount here. And I can say, oh, actually, maybe it's not a float. We're going to have a number that is the percentage. And it's like, oh, but it will be very helpful for me to do it with a float. I'm like, oh, you know what? OK, let's do that. Oh, but maybe the discount should be actually under the description or in the image. We can collaborate right now on those kind of things. And I can say, you know what? I need to think about it. You continue the way it is right now, but we'll let you know once we get once the verdict is done, and I will already put it in your mock. So you'll need to kind of be aware of that. And we're in agreement. I understand where he comes from, and I understand his pain, so I can give him the best as the catalog owner. I can give him the best service that I can. So just to recap, let's see. We basically had UP9 analyze the WebSock application traffic. We got UP9 to generate the traffic for the artifacts for us, so the tests, the mocks, the specs, and then we imported it to MockLab. We showed you how to we mocked the catalog service. We did the randomization of the price, and we made it like a huge number. We introduced faults and delays. And we also developed a new feature, at least on the schema level from catalog, so we can implement that new discount feature in the front end right now. And we also did that while we were collaborating. We didn't have to even go to GitHub to that. We didn't have to set a meeting for that. We can literally send a Slack message to each other, get the thumbs up, and get it done. So think of it, microservices, multiple teams, maybe tens of teams. They all need to work together to, at the end, get featured, get an application out of the door. That's one way to do that. And with that, let's go to our question and answers section. I think we have time for that. Noga?
Wow, thank you both. It's been fascinating. Let's see if we have any questions from our audience. This is the time. You can use the chat. You can use the Q&A button. I saw a hand lifting earlier. If you have questions, now is the time. Okay, so we have one question from Seth, and he's asking, let's say a developer is on his own and wants to get started. Do they have to get buy-in from the team, or can they just get started on their own and enjoy the benefits of the two tools? I think it's for both of you.
Sorry, but could you say the first part of the question?
So let's say a developer doesn't have, wants to get started, but doesn't have team buy-in, they just want to use it independently. Is that something that can be helpful?
Yes, so technically you can get UP9 installed even in your laptop, right? So if for example, you're using Docker Compose or Minikube, you can do that. You can talk with the with the developers, sorry, the DevOps, and kind of have it maybe on an integration environment and get all those to be created automatically. And as you get all the artifacts in your even in your GitHub, and it's yours to use for that. I guess for the MockLab, Tom.
Yep, so it's a similar story with MockLab. It's really easy to get started with it. You can sign up and use it for free, and you can create a mock API. There's a number of ways you can get started with it. You can go and create your stubs by hand. So that you saw me editing a stub there. There's nothing to stop you doing that from scratch rather than from something that's imported. You can import your open API specs. You can import Postman collections. You can, if you're a WireMock user, then you can import and export WireMock files to and from MockLab. So there's plenty of ways to get started, and you can, if all you want to do is create a single API and do some of your own testing against it, then absolutely you can do that, and there's a lot of value in doing so.
Great, thank you very much. Okay, and then we have an anonymous attendee. He doesn't want to, or she doesn't want to disclose their name, but the question is interesting. Is it about using UP9 and MockLab together, or can they both do the same things? Maybe Rafael and Tom differentiate a bit between the differences between the two and how they relate to each other, of course.
So from the part of UP9, we create the artifacts, okay? For example, all the artifacts that we create are based on open source. So for example, you've seen me talk about the contract. It's open API spec JSONs. You can literally download and upload them wherever you want. All the tests that we create are codified. So you can have it in Jest, and it's your IP, you use it. And the mocks, for example, is one. But in order to, once you have the artifacts, you can decide how to use them. So for example, I took the WireMock open source artifacts and just upload them to MockLab, right? I could have run that locally on my development computer, for that matter, right? So with UP9, we focused on generating those artifacts based on traffic, and allow you to do what I've seen with the try now, get some observability into how your application is working, see the traffic, do some troubleshooting and debug. That's the part of UP9 for that. And for the MockLab, I think this is where you want to kind of do the scale, right? So if I would like Tom, I guess that, for example, if I would like to run a performance test, right? And I'm going to run 100,000 requests per second. Probably I don't want to have my mock on my laptop or something like that. I want something more robust. So how would I use MockLab for that?
So yeah, so MockLab has a performance plan. You can start building your API on the free plan, but then if you want to do a performance test, you can buy our performance plan, get a much bigger dedicated host, which has got enough horsepower to support the level of load you want to generate, and then you can run performance tests all day and not incur huge bills with your SaaS suppliers or whatever. I suppose just to sort of further answer the question about can they do the same things, or should we use them together? I mean, I think that there are small areas of overlap. I mean, I suppose the mirror image of what Rafael was saying, that there's MockLab has got a very a recording feature, which I guess has some overlap with what UP9 does, but it's quite basic. It's good if you want to sort of capture a few stubs and get yourself started, but you get a huge productivity gain using UP9. As soon as you're into an environment with multiple services and lots of traffic to analyze. It's really about that sort of scaling up to a kind of enterprise size problem is where you really get the benefit of using the two products together.
Great, thank you. And Eugene is asking if it's enough to release a service to production with just testing mocks, or if you still need to test the live service, and if so, what is the gap? I think that's the $1 million question, right?
That's a really interesting one. I mean, I've done quite a lot of this sort of over the course of my career in various guises, and I would say it depends on the specific feature and the scenario, and I suppose you start to develop an instinct for this sort of thing for a while. So I think I would never advocate sort of completely doing away with end-to-end testing. I think there's always value in that final just validating that everything's wired up and you know, that the you know, everything really is sort of tried and true. I suppose the way I would depict this is kind of pushing things down your pyramid. I mean, as you know, as much as I think the testing pyramid has got some is showing its age a little bit these days, I think it's still somewhat of a useful metaphor for this. That you want as few slow, unreliable, you know, sort of difficult to execute tests as you can at the top, and you want to sort of push everything. Yeah, if you can get you know, confidence and validation from tests which are cheaper to run and easier to maintain, and you know, generally, you know, have kind of better economic properties than the ones at the top, then you should use those. And I've certainly from my personal experience, I found there are situations where you make trivial changes and you ship them. You know, you have high confidence that you're, you know, particularly if you're validating your mocks in the way we've talked about, you have very high confidence and you can go to production and there are very few problems. If you're shipping some enormous, you know, huge new feature, which is combining multiple API calls and, you know, where there are lots of moving parts, then I think in that situation, I would still, I'd still want the confidence of a little bit of end-to-end testing. But the big benefit of applying the techniques we've talked about is that there's usually much less to go wrong during that final bit of end-to-end testing. It's usually just a sort of formality. Whereas trying to do this stuff with, you know, where you're relying on that end-to-end testing is the place you find most of your defects, you end up in these very long cycles of sort of testing and bug fixing and re-releasing, and you know, the sort of low productivity that comes with that.
I think it's also, I will differentiate between services that are under your control and services that are being used like a third party, right? So when you can implement contract testing in your organization, and as time goes by, the contract, the mock, the test, they will become more and more resilient, and you'll be able to kind of trust them over time. But sometimes you have a third party and you need either somebody to create that contract for that third party, or you actually don't have a way to test it. Or let's say one of my clients in previous life, they had a chat third party. When they were doing something in production, wanted to test production, it was kind of an e-commerce website. They did an architecture change on their end, but when they ran the performance test, the third-party chat service actually was crashing. So after twice, we had to change the way the performance test flow works in order to overcome that problem. So if they crash, we can just eliminate that part of the script. A better way to do that would be to kind of have like either the DevOps or somebody in the organization to be kind of owning the relationship with that third party and create that mock for them. And then you can run the performance test without changing the test, but just mock that third party or not. And sometimes the third parties will kind of say, you know, you can stress test us maybe once a quarter, but we are not there for you every time that you want to do a stress test, or vice versa. You need to pay per APIs, and that is going to cost you a lot of money if you do performance tests. By doing the mocks, you're able to give your organization the agility to run as much performance tests as you want. And if the third party breaks, you can just move back to the mock and move forward with that in an easy way, not changing your script, because the script are the truth, right? You want that flow to happen. So that's another view to that question.
Thank you for that very thorough answer. Those are all the questions that we have, and we're almost at the top of the hour, so the timing is perfect. Thank you both. It was very, very interesting. We encourage everyone who attended to, first of all, join our future webinars and go to up9.com and mocklab.io and try these out for yourself. And that's it. Thank you. Have a wonderful rest of your day or a wonderful evening. And we'll be sending out the recording tomorrow or in the next few days. Thanks,
Thank you.
Rafael and Tom. Thank you so much. It was a pleasure.